Welcome to the SaferAfrica learning courses. My name is Sandra Vieira Gomes and I am a researcher from the National Laboratory of Civil Engineering of Portugal in the field of road safety. I will be your guide in Module 4 on safer roads. The Level 1 e-learning courses developed within this project are divided in 7 modules: concepts of road safety, data collection, road safety management, safe roads, safe users, safe vehicles, and finally post-crash care. You are now watching to the Module 4 on safe roads. This model includes 5 different sessions on road life cycle and general instruments for safety interventions at each stage, the driving task as related to road environment, impact of the safe system principles in road environment different stages, crash contributing factors related to the road environment, and methodologies to assess the effects of interventions.
We are now watching to session number 4 on crash contributing factors related to the road environment. This session is divided in 2 parts, one about reducing the accident risk and the other on diminishing the severity of consequences. This division was considered mainly because different factors have different effects. Some factors may contribute to the occurrence of a collision and are therefore part of a crash causation. Some factors may aggravate the effects of a collision and thus contribute to trauma severity, and other factors may not appear to be directly related to the road traffic injuries. So, as I said, I'm going to start to talk about the crash contributing factors related to the road environment that affect the accident risk. Due to the enormous costs to society of road accidents, the knowledge of factors affecting the likelihood of accidents has been an active research area for many decades. Unfortunately, detailed data which would help to identify the relationships between causes and effects are not usually available, like the driving data, for instance, accelerations, braking, steering wheel information, driver responses to various stimuli. Also roadway data and accident data, which may be available, for instance, via black boxes. A road traffic crash results from the combination of factors related to both the components of traffic system, comprising the road and their environment, vehicles and road users, and the way they interact. The weight of these components varies according to the specificity of the analyzed region. Identifying the risk factors that contribute to road traffic crashes is important to select effective interventions that can reduce the risks associated with those factors. The belief that accidents can be prevented if their causes are eliminated generated a variety of theories and models on accident causation that reflects researchers' view on the reality to explain complex relations in simplified ways. Accident models can help to understand the traffic accident phenomenon and to deal with questions on how and why accidents happened, where and when they take place, or who is involved and with which severity. Most researchers who address this problem have reduced it to the understanding of the factors that affect the frequency of accidents occurring in a certain geographic space, that's usually a segment or intersections, during a certain period of time, like a week, a month, a year, or a group of years. These models consist of mathematical functions that describe the relationship between road safety and explanatory variables related to exposure, such as traffic and length of road under analysis, and to risk, such as lane width or access density, amongst others. Once established, such models are a widely used effective tool, provided that their applicability to the concerned road context is validated and the appropriate level of analysis is used. Development of these models is a technically complex task to be carried out by a specialized analyst. However, it is useful to know the basic concepts underlying accident model to understand the potential uses and limitations of their use in safety analysis. The development of accident prediction models requires special care so that the results and interpretations made with them are the most correct. Several issues are important for the development of accident models, namely, the choice of potential explanatory variables and the type of model that better represents the data, the specification of the functional relations, the assessment of the model fitting, also called as validation, the limitations of causal interpretations of the fitted relationships, the evaluation of the performance of the model in estimating new cases, and the evaluation of potential causes of errors, like overdispersion or underdispersion, correlation between variables, reduced sample size and low sample mean, underreporting of accidents, omitted variables, amongst many others. In modeling accident frequencies, the most common form is a multiplicative expression, where A is the expected number of accidents, which varies according to the AADT, and a series of other explanatory variables representing accident risk factors. The effect of the various risk factors that influence the occurrence of an accident is usually modeled by an exponential basis function and raised to the sum of the product of the coefficients by the value of the respective explanatory variables. The most common probabilistic structure of the models used by transportation safety analysis for modeling motor vehicle crashes are the traditional Poisson and Poisson-Gamma or negative binomial distributions. Since crash data have often been shown to exhibit overdispersion, meaning that their variance is greater than their mean, Poisson-Gamma models are usually preferred over Poisson regression models because they offer a direct way to accommodate the overdispersion. Statistical models usually consist of two components, a systematic component and a random component, but may also include a link function used to specify the link between these two previous components. Considerable progress has been made in techniques for establishing the relationship between accidents, traffic volumes, and road geometry. Specific problems such as low mean value, overdispersion, disaggregation of data over time, and random errors were already identified by several authors, and new solutions and models were tested in the pursuit for better fittings and lower errors, as we can see from these examples. It is not within the scope of this session to teach you about the development of accident prediction models. If you want to know more about this, please check the references and further reading section. So from all the models that were already developed, it is hard to identify the variables that are more influence in accident occurrence and accident risk, since what is valid for a specific context may not be valid for another. Nevertheless, it is possible to list some of the most common variables influencing crash involvement. It is possible to see that not all the variables from this list are related to the road environment. This, of course, is due to the fact that it is impossible to dissociate the components of the system, as shown in slide 6, which all contribute to these events. We can identify that the defects in road design, layout, and maintenance, which can also lead to unsafe behavior by road users, are some of the most influenced variables in crash involvement, and also the inadequate visibility because of environmental factors, making it hard to detect vehicles and other road users. An additional source of information relevant enough to mention is the work done within the SafetyQ European project. So a decision support system was developed which identifies several factors related to the infrastructure as influence on accident risk. And the list is rather big and detailed information can be found for each one. Just follow the link and explore the site. Within the scope of this session, crash modification factors are also worth to mention, as they can be used to calculate the expected number of crashes after implementing a countermeasure on a road or intersection. Within the Highway Safety Manual, several crash modification factors were collected and are organized in a dedicated database, which can be accessed in the link presented in this slide. This database is organized by countermeasure, and for each one, several information is presented, namely the crash modification factor and its related error, and the information about its applicability as crash type and crash severity it is supposed to affect, and several information on characteristics of the application, roadway types, number of lanes, road division type, the speed limit, amongst many others. We are now moving forward to the second part of this session about crash contributing factors related to the road environment influencing the severity of the consequences. Factors that influence accident frequency may differ from those that affect crash severity. There are several methodological alternatives to study crash severity injuries, which can generally be grouped into ordered and unordered framework models. The ordered are more suited for examining discrete variables that have an ordinal nature, while the unordered response frameworks are applicable for discrete variables. Overall, researchers' options for one method or another depends mostly on the nature of the dependent variable and the differing methodological issues associated with the data. The development of these models is rather complex, but, like it was said for accident frequency models, it is not within the scope of this session to discuss the fitting of those models. If you want to know more about this, please check the references and further reading section. It is also hard to identify the variables that are more influent in the severity of crashes, and again, not all the influent variables are related to the road environment. But according to the World Report on Road Traffic Injury Prevention from WHO, from the main risk factors influencing crash severities, we find the existence of roadside objects, non-crash protective, one of the most influent variables. This is all for the session 4 on crash contributing factors related to the road environment. Thank you for your attention. You can download a PDF of this presentation from the website and also a PDF with references and further readings on this subject. I invite you to watch the 5th and final session on Safe Roads module on methodologies to assess the effects of interventions.